Okay, I'll be recording this as well na lang as yeah. Record siya. Sige lang. Okay, anyway, as I've said earlier, no, follow along na lang. Download the files for the prototype here sa uh, create with code, Unity create with code, and then under tutorial lesson 2.1, you should have the link for prototype 2 starter files. This will be the assets for the lecture today as well as next week Monday. Next week Monday we will meet, pero next week Thursday we won't. Okay. Sige. The goal or like the thing we'll do today looks like this. Ay, masyakit out. So, simple lang siya. We have our player sprite at the bottom of the screen. Sige, wait lang. Okay. So we have the player sprite at the bottom of the screen, and then there are random spawning animals, no, going from the top of the screen to the bottom of the screen, as well as our player throwing some like food. This is I'm using a banana sprite here. This is can also be configured with uh, controller, the controls, left, right, joystick, and then A to fire or to throw a banana. Okay? So simple lang siya for now. Okay? Wala pa na siya colliders or anything na would make our objects interact. So for now, it's just animal spawning as well as player going left and right shooting bananas. Okay? Sige, let's start with so I'll close this and let's start fresh, no? Okay. Okay, so starting fresh, so let's remove this scene. Ah, let's go to assets first, import package, and then, okay. So I already have downloaded the starter file, so I'll just import it again here. Just import everything. Okay, so under scenes, uh, so under scenes, you would have your prototype to scene. You just drag it to the hierarchy like this. And then our sample scene, since we won't be needing this, let's just remove it. So we only have our prototype 2 as our scene. We could look at the camera as well as the game window here. That's just how I laid it out. For this, I like to set the aspect ratio no, to be constant siya. So we could say 16 by 10 or 16 by 9. The usual resolution for games currently is 16 by 9. So we could just set it at 16 by 9. For the camera, we could click on the camera here. Tapos naka ano siya, we could see like the lines no for the camera. We could reposition this para medyo zoom out. We could move it on the y-axis para medyo zoom out until siguro around here no para covered. We have good view of the environment as well as wala siya sang like the black areas na we don't need. So we could set it like this. And then let's add our player sprite. So our player sprite, we can just find it in course library. Maybe here's the humans. Could zoom in a bit to see what they look like. So usually the farmer type lang siya. We could just, sige, I'll just drag one here, no, to the scene, and then I'll just rename this as player, just to keep things organized. Okay. Back to this. So si player, ano na siya this sa game view. You could also see now where it is right now in the game view. Medyo zoomed out lang. If you want to make it bigger, pwede man. You could scale it a bit. Sige, to, oh, it's not doing it. Okay. Anong lang, sorry. So pwede man siya a bit bigger like that, pero depende na sa inyo. Say I would just keep it 111 scaled. And then we could observe here, I usually reset this every time para naka-center siya. And then after that, I could just manipulate it like so. So for this case, sige, I want to position my player somewhere along here. So our Z is at -3. And then our goal here is to move the player from side to side. Wala siya forward motion. Doesn't have forward motion. And just side to side. But we also want to limit the motion of our player na dapat hindi siya magsobra sa scene, right? Or sa camera. So maybe I want my player to move on up until here. And then I'll just take note of that X coordinate. So here it says -21.1, or we could just round it out at the round number, no? Like -21. And then we could also move the player to here, the right limit, maybe also 21. So take note lang, we want our player to move from -21 to 21. That will be useful later on. Sige. Since we already know how to create user input or to utilize user input, let's create a script for our guy here. So let's just say this is player movement. And then we could just add this component of player movement. It's not yet compiled. Sige. We could just directly go to our player movement. We don't have anything with the start. So start now. We could just remove this. It's just the authors. Okay. So we don't have anything for start. What I'll do here is just a serialized field for movement speed. So private float move speed, as well as left limit and right limit. So left limit and right limit, this is for limiting our player movements para hindi siya magsobra sa camera. Okay? And to update, we know this already. We could just get the user input, no? We could say float, user X input like this, equal to input dot get axis. This should be horizontal. Okay, horizontal. Okay. This should be right limit. Okay. And then we could say maybe float move distance is equal to user X input multiplied by move speed times time dot delta time para hindi siya frame rate dependent. Okay. And then we could just say transform dot translate there. And then I'd say vector3 dot right. So vector3 dot right is a shorthand, no? If we look at this here, this is shorthand for 100. So this is movement on the x-axis. And then we could just multiply this with our movement distance, and we can move our player from that with that amount of speed. Because 1 times the distance is just the same thing. Okay. and zeros on the other axis will just be zero. So this is purely movement on the x-axis. Okay, so let's save this and let's go back to Unity. This should compile our script. Okay, okay, we could click on player and then add component, or you could drag the script as well, no? Say player movement. Okay, script is there. Sige, I'll do initial value, siguro movement speed is 20. Right, left limit, what did we have for left limit earlier? It's negative 21. And then right limit is 21, right? Okay, sige, let's save. Press on play, and let's see what it does. Okay, so we have movement na, left and right, but this still goes beyond the x-axis because we haven't coded that yet. We'll just provide an if statement for that later on. Sige, let's recenter our player somewhere here. Okay, sige. Okay, so let's limit our movement, no, player movement with some if statements. I'll just check my notes a bit. Okay. Okay. So for player movement, we could say we could keep this, no? We could just keep this on transform and dot translate. But we could have a few if statements here that we could say if our x position of our player, so we could get that transform dot position dot x is less than left limit. So meaning nag-exceed na kita sa left limit because that should be negative. Be careful, no? I'm using less than left limit here because there are some errors if you do less than or equal. Maybe it's not the same thing. But I'm using left limit here. And then we could say transform dot position. We are forcing our player to stay on that x coordinate. So transform that position, new vector 3, and then we could say left limit, and then for the other axis, we could just say transform dot position dot y, and then to keep the z, we could also just say dot z like this. Okay, like new. What is this? Uh, that's fine. It's probably intelligence lang na issue. Okay, and then we could also do else if for the right limit as well. So you could just copy this, but this one should be greater than right limit. Let's copy this and say this should be right limit. Okay, you could also like clean up your code, no? Like you could you could have your transform that position into a variable, etc. So depende lang. You could do that as well. So let's go back to Unity and see how it goes. So that should compile. And then, oh, says vector 3 some, oh, I might have deleted something. Ah, so nag-double import siya because of IntelliSense earlier. This should be better now. Okay? It's still big. Okay, wala. Okay. Okay, so now if we move here to the right limit, limited na siya on that X coordinate. If we move here, it's also limited to that coordinate. I feel like our player is a bit slow. Let's see 40 bit. Okay. So this is better, no? Maybe with motion. Sige, let's edit that to 40 para ma-save siya for that player. Okay, so we have our player motion, easy lang. Next thing we'll do, we'll have the banana or our food that we are throwing earlier, no? Like our projectile. So what I'll do, under food, maybe I'll just get something here. Say sandwich. I could drag it to the hierarchy like this. There, it's very small. Looks like that. It's very small. So we could do some scaling with this. We could restart this first off, and then scale this maybe 3. There, para mas visible siya. But it looks like a square lang, no? Maybe we could have another thing na mas visible. Say cookie. Okay, for your cookie, if we scale this, okay, it's a bit better, not the best still. So yeah, let's just say okay. I guess the fish looks better. So yeah, let's just deal with the fish. No. I'll just rename this as fish. And then we'll do some scripting with the fish as well. So the projectile we've seen earlier just moves from bottom to top. No? A point of origin is the user. Sige, let's do first just a simple script to make our fish go up. Let's just say this script, let's just name this as move forward because it will make our object move forward. Okay. Okay. Let's edit this. So to start, we don't have anything. To start, we just put something in update, right? So similar. Okay, start. We could remove this. And then for this variable we're concerned with is just move speed, right? So we'll just have a move speed here. And so I'll have it maybe 40F starting value. We could edit it later. And then under update, we could just say transform, translate. This one moves forward, so we could do vector 3 that forward times move speed times time dot delta. There. So it moves forward. It moves forward with move speed independent of frame rate. So very simple code. Okay. So let's drag this to our fish. We click on fish. We have our mesh renderer and we have here move forward. So let's see what happens now if we click on play. It's a bit hard to see there, but it moved forward, but then it's gone, right? Let's do it again. Not sure if you see it. Can you see it moving forward? There, it moves forward. Maybe okay naman ang speed, so let's keep it that way for now. But what we want here, no, for our fish, is to be created when the user inputs something, maybe like a fire button or a throw button. So for that, first we have to store this fish as like a blueprint, no, for other objects that will instantiate later on based on this fish. So for that, we'll create this as a prefab or like a prefabricated object. So to do that and to keep things organized, now we could create a folder and then I'll just say custom prefabs, prefabricated object. Okay, I'll go on that folder and we'll just drag it from the hierarchy to the projects folder there. And then it will ask us if we want it to be an original prefab or a prefab variant. So take note, this one, our fish here, was previously a prefab already provided from the package. But for now, let's do this as an original prefab so that when we edit this prefab, it won't affect the one that was provided by Unity for us. So this is an original prefab. So whenever we create an instance of a fish, it will follow the same. It will follow the same behavior. No, it has a movement script, etc. Okay, so for now, let's have that fish there. No, the next thing we'll do is to create sort of an input or an input catch as a player that will make our player throw food. Okay, let's go back to assets. Since this is getting a bit cluttered, let's create another folder for scripts. Okay, so it's under scripts. So we could add that. We could add the like throwing of food in player movement as well. Pero a better practice is to create another script, no, for just exactly for the throwing of food responsibility. In OOP, that is following your single responsibility principle. Okay. So let's create a C# script. This will also make our scripts a bit more modular, no? So if we want to have changes in throw food, we only have to make changes in throw food and not make changes in player movement. And vice versa. That follows our OCP or our open close principle sa object-oriented program. Okay, let's name this throw food as a script. Okay, so for throw food, this is sort of easy lang. We'll remove start for now. We don't need that. What we want here is a sort of reference to our throwable object or through the with a fish. No, with how we can do this is we could do this public, but as I've said before, no, I prefer serializing so that we keep the access modifiers intact. So we could have private, and the data type for this is game object. So we want a reference to a game object. This is similar to what we did sa camera, no, on the previous exercises. So we get a reference of that. So private game object as a food projectile, like this. And we won't initialize this whatsoever. We'll just create a reference of this later on sa Unity. Okay, let's close this. So for that, okay. So for this, we could just say if a button is pressed to fire, we create the projectile, right? So for this, we could use our input dot. We could use get access, but we'll see like how it goes later. No? For now, let's say get access, and then let's go back to Unity for now, and let's look at which axis input manager we can use or what input makes sense. So edit. Let's go to project settings, input manager, under access. So I think this would be better put sa fire one. No, let's check what happens sa fire one the axis. So the name is fire one, and the positive button is left control. There is an alternate positive button mouse zero. Mouse zero in this case is our left click or the main mouse button. Mouse one is our right click, and then mouse two is our mouse wheel. If we click our mouse wheel. So here, if we click, no, left click, this will be activated, fire one. Sige. So we can use this, say get access, fire one. So if fire one, this will return a value of float, no, from -1 to 1. So let's just say if this is equal to 1, meaning our fire one is pressed, we'll create our banana or our not banana, our fish. So we could say this is a function from Unity. No, this is not a function from C#, because when we create new objects, we say new. But for Unity, when we want to create a new game object, we call instantiate. Now, usually instantiate has a lot of overrides, but the one I like to use takes three parameters. The first thing is the game object we want to instantiate. So let's say food projectile, we want to instantiate our food projectile. The next one is our transform, which is usually a position. In this case, since I will be attaching this throw food na script to our player, I could just say transform dot position. Yeah. Okay, yeah. So transform that position, meaning this will spawn wherever my player is. The last thing is usually rotation. So if you want to keep the rotation of your object that you want to create, we could just say quaternion dot identity. So this is just saying preserve whatever rotation we have. So it's basically 0, 0, 0. Okay. So again, let's save this and then let's attach this throw food okay player. Okay, I'll click on player. Tapos I'll just do add component through food. There. And this one asks for a projectile. No? We could go back to our custom prefabs and let's just drag. So this one, no, this is not from the hierarchy. This is directly from your projects folder to our inspector. So we have sort of like a prefab or like a blueprint of the fish we want to throw. So this one will be referenced whenever we call the instantiate from the script. So again, let's save this. And let's click on play. Let's see what happens. So since the fish that's already there is already there, it will just move now. If we move our player around, there, if I click, there's a fish. But you'll see some sort of problem no? If we hold on to our mouse, it fires multiple fishes. It's not really what we intended. What we intended here is if we click, it just fires one fish. And as you see, it is not getting destroyed. It stays on the hierarchy. So this will populate your hierarchy and well, memory consumption siya. This will make your game slower. So what we want here is that our fish will be destroyed at some point, no? Maybe timed siya na destruction, or maybe if it crosses a barrier, it will be destroyed. What I usually use, sa Create with Code, they will teach you that if it reaches a certain coordinate, it will die or it will get destroyed. What I usually use is timed siya na destruction because that's I think that's better for me. It works better. It's more uniform like that. But anyway, okay, let's first address the issue of multiple firing of our fish object now. So let's go back to our throw food. So instead of get access, no, because this just gets like a prolonged click or a prolonged press of a button, we could say instead get button down like this. This one returns a Boolean value, so we don't have to equate it to one or compare it to one. Boolean value siya, so this just says if in this specific frame, this button is pressed, in this case fire one is pressed, then instantiate. Sige, let's go back. Okay. Sige. So here, so I'm moving around. If I press on click, oops, sorry. If I click, isa na lang ang gagawa. Okay? So multiple clicks, multiple fishes as well. Pero one click, one fish lang. That's what our intended functionality was. Also, we can do something like some settings to have this available for our joystick as well if you have a controller. So this one, I've already searched this, but I want this to be in the A button. our firing would be in the A button. The A button is your 14th axis. So this will listen for an input sa 14th axis, which is the A button. For a complete list of that, we have here, no? Okay, it's loading. So there's a table here. So our A button is joystick button 14 or our axis 14. We could listen to that. And we have D-pad as well, left trigger, right trigger, etc. Okay. So here I am doing, I'm catching it at the 14th axis, meaning A. Okay. Sige, I'll close this and I'll play again. So our movement, horizontal movement is with the left joystick, no, as usual. And then these other buttons don't have anything. If we press A, there's a fish like that. Okay. Okay. So we dealt with multiple fish na semi-automatic fish firing. Manual na siya sa boat, or fully automatic rather. It's now semi-automatic. Okay. The next thing we do is to destroy the fish when it has reached a certain point or reached a certain time on its life. Okay. So for that, let's go to our scripts folder. Let's create another script. Say C# script. And then say, okay. For this, I'll call it, wait lang. Okay. For this, I'll call it timed destruction. Kind of grim for a name, pero it is very descriptive of what it does, no? It's a time to be destroyed. Okay? So for our time destruction, our variable concerned here is just the time it has to live. So we could serialize that. Serialize field, say private float. Let's say this is time to live, like this. I'll initiate this at 1 second for now, 1F, okay? And then I will create, so there are better ways to do this as well, but this is a very rudimentary way. We'll create sort of like a variable for time elapsed. So private float, time elapsed. And let's just say 0. I'm starting now. To update, we just say time elapsed plus equals time dot delta time. So what this does is just accumulates the time, no, per frame that it has accumulated. And then we'll just create an if statement here if our time elapsed is greater than or equal to our time to live, meaning it has reached its time limit on our good green earth, we'll just say destroy. Okay, so destroy will destroy an object. Okay, and what we want to do here is self-destruction, right? So we'll destroy this object. To do that, we'll input here game object. So again, notice, no, this game object starts with small letter G instead of big letter G. Big letter G calls the class name. This is a variable. This variable pertains to our game object, namely the fish, because we'll connect this to the fish, right? Same thing with your transform. Transform with a big T refers to the class. Transform with a small t refers to the component. Okay. Okay, let's attach this time destruction. Sorry. Time destruction will attach this to, we can attach this to the fish here, but what I want to do is actually attach this to the prefab. So we could go to our custom prefabs, click on fish here. There are values in our inspector and add the component here. Time destruction there. 1 second. So what this does is it actually edits or it actually attaches the script to the blueprint, not the game object in the hierarchy. In fact, we can just remove this fish from the hierarchy because we don't need it anymore. If we want changes on the projectile, we could directly go to the prefab, to the blueprint. Okay. So this one has a time to live of 1 second. I think that's fast enough, no? Or that's long enough for it to live, to go out of the screen. Okay, but let's see. Okay, okay. So okay man siya? It just goes there, no? It reaches the end of the screen and then we don't have any view of it. Let's inspect the, oops, sorry, the scene from the scene view. If I click, there it reaches and then it will eventually die. If I click, no, there it eventually destroys itself. So even if I click so many fishes, they all die after 1 second of spawning. There, cool. There, okay. Sige. So what we have now is our player movement. Our player also throws fishes, etc. Yeah. Sige, let's click on play again. I just want to check on something. Yeah, that's fine. Sige. Okay. What we want to do next is our herd of animals, no, that are going from the top of the screen to the bottom of the screen. So okay, let's check on what we can use, no. Let's say we have animals here. We have dogs, farm, and forest. So okay, let's have some things from the farm. Let's say a white cow. Let's put it on the hierarchy like this. Let's say a brown cow. Okay, I will spread them out later. And then say maybe another animal, maybe from the forest. Let's have a moose. A moose looks like that. Okay. So let's spread them out para better. You can identify them one by one. So the moose looks like that. Brown cow looks like that. And the other cow, the white cow, it's like this. Okay. So this one, we want to rotate this 180 degrees because we want this to face downwards. So we'll just say 180 there, 180 here, and another 180. Oh, that's the that's the Z. Okay, actually, let's remove the brown cow na para may variance. Okay, let's put in a dog there. Animals. Let's put in a dog there. Maybe like a bulldog, something like that. Okay, but I think that's too small. Let's scale it up a bit. Maybe 10, like a big, really big bulldog. Okay, and then let's turn it around 180. And then let's put it here. Our cow, our white cow, I want this to be a bit bigger as well. Sige, let's say 0.15. Yeah, that seems reasonable. Okay. Okay, that's a big cow. Okay, maybe 0.12. Okay. Our moose, I want this to be a bit bigger as well. Sige, say 15. Okay, that's big enough of a moose for me. Sige. Okay. So for cow, I'll rename this just simply cow. For our moose, I'll also rename this as just moose. Moose. And for bulldog, I'll just rename it simple, not dog. Like that. What we want to do with these, we want them to move forward as well. So since we already have the script for move forward, let's just attach that. Move forward and move speed. Let's say for a cow, this moves a bit slower. Say it's going to move 7. Just we can adjust this later on. Our moose, say, moves a bit faster, no? Let's say our moose moves at speed 10, and then our dog a little faster. Let's say it moves at speed 12. Okay. So let's position them like so. Okay. And then let's just click on play and see what happens. Okay. Not a lot of difference with the moose and the dog. maybe I'll update the dog movement with like faster. Okay, I want it a bit more agile, say 15, like that. So the good thing about move forward, no, is it's not just for the projectile. We can also use it for other, like the animals that moves forward. So script recycling, that's good. Okay. Sige, we'll have that. We'll have those for our animals. For our animals as well, we want this to have a some sort of spawn. So for that, we could create sort of a spawner. No? If you played Minecraft, there are things, no, like a block of like a block in Minecraft that spawns enemies. We'll do something similar here with Unity. What I do usually is I click on hierarchy and create an empty object, and then we could name this as animal spawner. Okay, and then we could add we could add a script to this. So I'll just go to scripts, uh, scripts. I'll create a new script, animal spawner script. So this will spawn animals now. Let's go directly to the script and add some things. So the first thing we want is a reference to the animals we want to spawn. So the animals we want to spawn here, we have 3 that we want to spawn, right? We've identified 3, but we can add more. Okay, so for this, we could have another serialized field, say private what we the reference here is also game object, because that's the general term for game objects. So big letter game object like this, and we want this to be multiple game objects, right? We don't want na one game object for moose, one game object for dog, one game object for cow. We want this sort of in an array, right? When we already know arrays, since uh that is very common in programming. So to define an array in Java, or not in Java, in C Sharp, we could just use the brackets, empty brackets. That means this is an array of game objects, and then we could just call this animals, like this. So animals is the identifier or the variable. Let's remove the start. We won't need that for now. And then let's populate your animal spawn, or your array rather. Okay, so let's attach our spawner, our animal spawner script, to our animal spawner na empty object. This, and we'll see on the inspector, we have animals here. So this is our array of game objects. So if we expand it, there's nothing here. This is empty. So we can add game objects here, and we could just literally add game objects. However, if we want to add from the hierarchy, measure tricky siya, what we want to do is to create prefabs of the animals we want to do, or we want to use rather. So drag it from the hierarchy down to prefabs. I'll do original variants. So my prefabs data of our animals. So for that, after that, we'll go to animal spawner, and then just drag our prefabs. So one for cow, one for dog, not fish, one for moose. There. You could further, I don't know, you could further like organize the project window. You like create another folder for just animals, etc. But I won't do that for now. Okay, so we have an array. We have an array of game objects. What we want to do is sort of a randomized siya na instantiation. So we could also do na it will only spawn every 3 seconds or so. So we could say another private float time elapsed like this. Yeah, time elapsed. And then we could have another serialized field for float. And then we could call this spawn interval. Okay, so to update, we could say if spawn interval is greater than or equal to spawn to time elapsed. Forgot something. Time elapsed plus equals time dot delta time. just similar way, rudimentary way. There are other ways to manage this, such as subroutines and coroutines. But we'll clean up our code later. No, we'll use those. But for now, easy implementation lang. If our spawn interval is greater than our time elapsed, we will create an animal. But we want this to be sort of random as well, right? So let's first get sort of the index of, or index, or just choose a random index of the animal we want to spawn. So indices, it's not float, this is int. Say we int random index. Okay, and this is, we can have our random function. This is under our random class. Say random dot random range. So this is the method, no? And this is a range of random numbers. This will be either int or float, but since we have int here, this should also be int. So 0 to, we will have the length of our array. So animals dot length. There. There is use random range. Okay. Random dot range. Sorry. Okay. So here it says range int min inclusive. So 0 is included, and then max exclusive. So meaning 3 is not included. So this is just 0, 1, 2. But for float, if this accepts float, this is inclusive for both. But here we only have min exclusive, meaning 0 is included, and 3 is excluded para hindi kita mag-index out of bounds. Okay? Then we could say instantiate animals at the random index. Let's say our transform position is just the same with our spawner na position. And then quaternion identity. Okay. This will be, sige, let's look at sige, I'll say spawn interval is 1 second. Let's look at the behavior of this. Okay. First, let's go to our scene view. Let's click on animal spawner. We can't really see it. I'll reset the position. It's now 0 there, 0, 0, 0. Just for just for us to see the spawner, we could sort of have a stand-in sprite for this, just so we could see it's a scene view. But we could just delete it later on. So we could get some random sprite. I'll get the simple farmer here, and I'll just drag it as a child of animal spawner para may visual representation now. And then we could move this around. Say, sige, so I'll say let's move it here. Okay. And then let's look at what it does. It should have the animal spawn. Okay. Spawn interval. Okay, that's a lot of okay. What happened? Anyway, okay, let's try to do that again. I think I know what happened. Sige. Let's reset. Our animal spawner is actually not there, but here. Okay. Okay, I think I know what happened. We forgot to, or I forgot rather, I forgot to make our time elapsed back to 0. Is equal to 0. Okay. But there are still other problems. See later. Okay. Oh, what? Ah, that's one, right? I wait. No, one. If no, that yeah, what is that? Right. So if our time elapse is greater than our spawn interval, okay, should be correct now. Okay. Okay, so it's now spawning random animals, but it's facing there. Diba? It's spawning it upwards. It's not what we want. So we could rotate our animals, no? So spawning mismo. Uh, and what I also want to do here is to move it or to move the spawn sort of random x-axis. So to do that, we could have, so the first one we want to fix is instead of quaternion identity, we could have quaternion Euler. So this will take angles, no? So we want to rotate it in the z-axis. Z-axis, good man. Yes, no, y-axis rather. So we could put 0 and then 180 sa y-axis and then 0. So this will spawn na naka rotate. What we also want to do is sort of like a random spawn range. So we could serialize it. We could also just freehand it. I'll serialize it just for, I don't know, just for visualization. I'll say this is left range, and then say right range. I'll say we'll just do this same as the player, no? 21, negative 21 to 21. And then I'll just call sort of like a random function to create an offset, sort of offset. So we could just say, okay, okay, float random x chord is equal to random dot range. Sige, this is from left range to right range. So since this is float, if we look at this, this is both float, no? So max inclusive, min inclusive. So meaning negative 21 and 21 are both included. It's a random function. Okay. And then we could say new sorry, vector 3 new vector 3 sige, vector 3 that right, and then we'll just multiply this with uh, uh, vector 3 that right, we'll multiply this with random x coordinate. So now multiplied by 1 would just be 1. So offset will be whatever x coordinate, then 0, 0. And then we could say another spawn point, vector 3 spawn point is equal to our transform position. Transform dot position plus our offset. Okay. And then instead of transform position here, we'll just click on spawn point and then like so. Then we'll reposition our spawner so that it is in sort of the middle of the scene. Sige. Let's set our x to 0 and then our z to about just above the screen. Just above the game scene para hindi to siya makita kag-spawn. Okay? Okay. So there, spawn there, spawn there. Yeah. So medyo ano na siya, medyo randomized na ang spawning. It's from left limit to right limit. Okay? With for the x coordinate. We just have another problem similar to our fish earlier. It will populate our hierarchy too fast. So for this, we could just attach. So we'll go back to our prefabs. We'll go back to where is my prefabs. Okay, just go back to our prefabs and just attach your timed destruction. So for this time destruction, time to live for cow, since it's a bit slow, let's put it 5 seconds. Okay, for dog, since this is a bit fast, we'll put it at 3. And our moose, let's say 4. Okay, and let's see. Okay, there it's spawning. And then, as you see, no, it's not being overpopulated here because they die as soon as their time to live is exhausted. So for the cow, it dies right there. Yeah, something like this. Okay, gets okay. So for today's lecture, now we'll stop here. Next lecture, we'll do some collision detection with colliders. Para when we throw food to our animal, it could disappear or go somewhere else, or just die. Depends. Depends on what we want to do with our game. As well as we'll clean up some parts of our code that are kind of rough. No? But for now, we'll stop here and then I'll see you next week, Monday. We'll hold class next week, Monday.